This video is about one simple little application that I think is probably interesting to most people at the moment. What I've done here is used Jam.py to connect with the Gemini API, which is Google's large language model, and that's got a simple example of how to do that, which I think is probably something that people are all interested in right now. So what this does, it lets you select a PDF. Let's go ahead and actually add a new one here, and you pull up any PDF that you want. Let's see here. That's a big one. Get something small here. Okay, there we go. Do this checkout, and it sends the PDF to the Gemini API and tells you a summary of the document. So it could be really anything, and then you've got that stored in the application. So the file and the timestamp, and if you add any notes, you can store that all in the database. I'll write a little note here. I'll delete this so you can see that's just a little CRUD application. And I don't think there's anything new in this application as far as Jam.py is concerned, but I'll go through a little bit about how you do this with the Gemini API in case that's something that you haven't seen before. It's a nice use case. This is really applicable to really a ton of different domains. Doctors can use this to look at x-rays, and professionals who work with documents can use it to check documents. You can send whatever prompts you want to the API, just like you would in a chat, but tie it into your application. So what we got here is a single journal. You can see already from the application there are 4 columns in the database. So we have an AI summary, which is going to be the text returned by the API. So notes. So we can just type some notes in there ourselves. There is a file column, where we're going to use the built-in features in Gem.py to upload files and then interact with those files and send them to the Gemini API. And then there's a timestamp column, which stores the current date and time when we do the uploader. There's a client module, and there is a server module. Client module is very similar to what you've seen in the past. We are going to respond to a field being changed. So when we upload a file, we're going to do something with the file. And here I've just put a little conditional here to make sure that the only file we really want to respond to being changed, or not the only file, the only column value that we want to respond to when it's changed is the PDF column. So if it's not the PDF column, we just exit this function. So we've got a little file, or a little handler here for the on-field changed event, and then the rest of this function just gets the file. So from previous tutorials, you may remember that when we have a file, the lookup value for that file object is a path. It's file path. It's the actual name of the file, and that is stored on the server in the static folder in the project, and in a subfolder called files. So we're going to be taking that file name, and then we're calling on the server a function which we've called analyze PDF from table. We're sending it the file name, and what we get back from that function will be the AI summary, and if there's an error, we handle that, but if there's not an error, we set the field of the current row where we've uploaded the file to be that value, the summary value, to be that data which is returned from the function. So very, very simple front end. Most of what's going on here is just some error checking and validation. Okay, so in the Python file, so on the server, the code we're running is within this function here, and that calls a couple other functions. So this is our function which actually does the sending to the Gemini API, but there is another supporting function here which sets up the Gemini client. And to do that, we need to, on the server, install a library, pip install a library called google.genai. That will give us access to the Gemini API. And you can do that by going to aistudio.google.com, get yourself an API key, you can get a free one. For this example, I'm using Gemini 2.0 Flash Experimental, which has a massive context size, so you can upload huge files and it doesn't choke on it. And you can actually, you can see here we've got a million tokens here, and some of these models can have handle up to 2 million token context sizes. So go ahead and get your API key there. And what you're going to need to do in order to build the application, a little bit on the server. So I have this, and you've seen this in the previous tutorials. I've got this in a folder called Gemini on the server. We have a Python environment called Gemini set up. And so what you'll need to do there is, let's go ahead and take a look here. I wrote some instructions here, and I have this whole file uploaded. I can see we're getting a server request error because I've shut down the server. But importantly, what you need to do, first of all, is in order to run the Gemini API, I have to be using a newer version of Python. So I have this running on Ubuntu 20.04 right now. And I don't want to replace my default Python interpreter. I have other software running on that server that's currently just set up to use Python 3.8. So what we want to do is set up a newer version of Python. So what I've done is set up Python 3.11. And here is just some commands to do that. You can use the apt install, commands to download another version of Python. This is what you do. Of course, you can use ChatGPT or some other AI helper to help you learn how to do this, but this should be everything you need to do on a Linux system. On Windows, you can just download a more recent version of Python and install it. So you run these things and you will install Python. And we're going to put it in a particular folder, which we'll be able to run using the Python 3.11 command. And then from there, everything is pretty much as normal. We're going to run a virtual environment, call it Gemini, change into that directory, activate the environment, and these are the things you do a little bit different on Windows to make that happen. And then we're going to pip install Google Gen AI, and also going to install Jam.py. So all the normal stuff you're used to doing, just doing it with a newer version of Python. So make sure you have that. Then finally, what we need to do, the way I did this here to have an API key, is fairly typical. We're going to make this a environment variable, which will pull out of this environment variable. So these are how you set up environment variables in Linux and in Windows. So in Linux, you use the export command. You set your environment variable, this variable, which we'll call Gemini API key, to whatever your API key is, whatever you got from Google. In Windows, you use the set command, set that in your command console. So you do this here in your command console, whether on Windows or Linux. You can also do it in Windows PowerShell like this. So that sets up a environment variable. And go ahead and run our server here. And we need to, in order to read that environment variable, we need to import the OS module. This is from the standard library in Python. And that will enable us to get an environment variable. And we also, in order to interact with the Gemini API, we need to import these modules from the Google Gen AI library. And we're going to set a variable here that will hold the client object for Gemini. And we've got a function defined here which will initialize the Gemini client. And you can just get this from their documentation. There's not much new here. All I've done here is set our API key using Python OS module and the get environment function to our environment variable that we set at the command line. So this will grab that from the environment that this application is running in and handle some errors here. and then we'll run this genai.client function, set the API key to what we've now gotten from the environment, and if it's properly initialized, it will print out a notice, and otherwise it'll give us an error. Okay, so that is the get Gemini client. That's straight from the documentation in the Gemini documentation. Okay, so then we have this function which we've created, and what we're going to do with this, we're going to initialize the client, handle some errors if we need to, and then put this all in a try except evaluation so we can handle any errors also. But basically what's going on here is we've passed this function. We always pass the item value from the front end, and then we've passed the PDF file name, which we've gotten from the file that was uploaded. That was in the front end function. So I've seen this a few times. I'm hoping this is fairly straightforward now. But pass the file name here. If there's no file name, handle the errors. And then we're getting the file path. And I mentioned, you've seen a couple of the other examples, that uploaded files are stored in a static subdirectory and a files subdirectory within that. And so we concatenate the file name with that path to get our file path, handle any errors, and then we open that file, read the bytes from it, and then we send that data over to the API, the client API. So this is the important part right here. You get those bytes out of the file, and we set a prompt, set a model, and then set the contents, which we've done up here by opening the file and getting the pieces of that file that we need. And that's it. That's as simple as it is to send a request to the API. So this is the key bit here. I'm going to get a file name that's stored on the server, and this comes from the Gemini documentation. You can see how to do that, but we can attach a file and send a prompt. That's the key. And then from there, we've got a variable. By doing that, we've set a variable response. We get the text response from there, handle some errors, and that's it. Return that response text, otherwise return some other messages. And that's it. That's all it takes to build this application. So I'm going to go through it again really quickly to summarize. We create a table here to store what we want, most important of which is the file column, where we have a file type. And then in our client module, we respond to the on-field change. So when we make a change to something in the form, we ensure that we're dealing with a change to the PDF column. When that happens, we get the lookup value, which is the file name, and we send that file name back to this function on the server, and then we change the AI summary value in that column to what the Gemini API returns in the back end. So this function is, again, just run through it really quickly to summarize it all. Do all our imports, set up our API key in the environment, the local environment on the command line, and then we have this initialization function. Just have to basically give it our API. We use this GenAI client to do that, and then for our function, we're calling that function which establishes the client, and then getting the file name, concatenating it with the file path, sending that, reading that data, sending that data to the Gemini API along with a prompt, and within that call we're also selecting the model that we're going to use and setting the contents of this this API call to be the prompt that we've defined and the PDF data. And you will notice that the prompt that I have here is just very simply, please summarize the attached PDF. In other applications, those prompts can get to be pretty darn complex and interesting. And just like you have probably seen working with any sort of ChatGPT model or DeepSeek or Claude, a lot of the power of this functionality is going to be enabled by how well you engineer this prompt. So for example, if you're dealing with documents specifically and you want to ensure that the model doesn't return lots of false positives, you can give it instructions to that about that goal and make sure that it knows what sort of information and how to prepare that information and how to think about the data that you need and how to evaluate the data in documents that you might be evaluating with this API, and you can direct it to perform computations and to organize data or to do things with the data that it finds in documents, and present it in a certain way in the results. So the code itself is very simple. We've got just a few dozen lines of code, even with all of the error checking. And of course, we can eliminate a lot of that error checking. It comes down to a few core lines here. Learn how to do this. And of course, this is all in the Gemini documentation. And the integration with Jam.py is very simple because we can get the file data, upload the file data very, very simply, and that's why Jam.py is so fantastically productive, and we can create our database to store all these answers very, very simply. So hopefully that's an interesting little example. I show a little bit what these responses are like. So this was a gift certificate. It looked at an image and saw exactly what was written on there, and I've just asked it to summarize these documents. But this was the first chapter of a well-known book, and so it summarized that little bit. And of course, you can instruct it to go into more detail, the AI to go in more detail on your prompt. This was a PDF brochure, and it does an absolutely fantastic job. And so to be clear, you could do this with any of the other APIs. And in fact, one thing that I'll do a lot with these models is, and the services that they make available is interact with more than one model. I'll get output from one model. So for example, if I need to generate some code, I may have one model generate some code, then I'll have another model evaluate that code and maybe go through a couple rounds of doing that with more than one model, and have a whole series of calls which pass the output of one model back and forth, and have each model evaluate and change and make suggestions and pass all of the output from each of those models to the next models so that they can work together. And it's kind of like working with a team of people that can reason about the output. And very often one model can see a perspective or catch a misunderstood bit of a prompt and actually help to solve the problem in better ways. And that's, I think, a really good strategy for dealing with this. So you have all the tools you need to work with AI models and do some of these really fantastically interesting things that are pretty simple to do these days working with APIs. Gemini is particularly good at dealing with large context windows, lots of data, and images in particular. It does an absolutely phenomenal job of really seeing even handwritten documents and images and reasoning about what's in those documents, and evaluating and calculating and performing actual human-like work when it comes to looking at documents that have been scanned, even messy documents when they're scanned quickly. Of course, DeepSeek and the other reasoning models are great at really kind of looking at all the possible outcomes of its response and thinking intelligently and reasoning even more intelligently. So combining all of those potential APIs and using some on the back end, if you have a machine that's powerful enough to run a local model, you can do some work that might get expensive. But at this point, Gemini is extremely cheap to run. It's 10 cents per million tokens input and 40 cents per million tokens output. And they have an even cheaper light version So doing a lot of work very recently has become really inexpensive. So hopefully this is helpful and gives you a little bit more of a use case for some of the things that have been covered in the other tutorials. Hope that helps.